Alright, Honors Algebra 2, welcome back. This is a first video I've made in a while. Let's do a shout out today to, I'll do the group right in front of me in 7th hour, Paige, Kimmy, Allison Bieber, and Zach. I hope you guys are watching this. Actually, you all should be watching this. So today we're going to talk about angles of rotation, reference angles. There's a lot of things that are already written down for you on your notes sheet, so let's just go over that. On a coordinate plane, the standard position of an angle is this. So look at your diagram. Pretty much we measure angles from the positive x-axis and then go counterclockwise. We call the initial ray the one on the x-axis, the positive x-axis, and then the terminal ray is where it ends. Angles that open counterclockwise, like the one that is above, have positive measures. So let's write that in. Positive measures. If they are going the other way, if we're starting at the 0 and going in a clockwise fashion, then they have negative measures. And directions on a graph are indicated by an arrow. There's some poor grammar by Mr. Vranek. R. Anyway, let's forget about that for now, and let's look at these examples. Basically, all I want you to do is sketch the angle. So, example 1, 45 degrees. First of all, we're assuming that you guys know, just in general, that 90 degrees is straight up, 180 is half a circle, 360 is a full circle. So 45 degrees goes from the 0, and it's about halfway between 90 and 0. So this, and again we indicate it with an arrow, would be 45 degrees in the positive direction. If you have any questions, please jot them down and we'll go over them in class tomorrow. Example 2, again, we're always starting, even with negative, we start in the x positive direction. But we do not go counterclockwise this time, we go clockwise. And since negative 90 is 90 degrees, we're going a little bit past 90, so we're going to go about there. And I would say that this is negative 108 degrees. Okay? You don't have to be exact. I'm not asking you guys to pull out your protractors, because I know you all have a protractor on you to measure these angles exactly. We're just kind of sketching. So, all right, number 3, almost 360. Well, almost 360 is almost all the way around. So we're going to start here. We're going to go all the way around to about here, and that would be 320 degrees. It's still positive, so we're going in the correct way. Now, radians. We talked a little bit about radians in the lab yesterday, which we're doing on, actually coming up on Tuesday here. Radians, pi over 6, if you convert that, 1/6 pi is the same thing as 30 degrees, because 180 divided by 6 is 30. So, and pi is 180 degrees. So, here's what you can do. We're going just 30 degrees in the negative direction, so that's about there. And since it's negative, and that would be negative pi over 6. If you still, because you just learned about radians yesterday, if you're still having problems with the knowing what pi over 6 is, take the moment to just calculate it by multiplying by 180 over pi, and then get the degree measure so you know where it goes. But on your diagram, you have to label it with the correct measurement. So here it's a radian. All right, 5 pi over 4. Well, pi over 4 is the same thing as a 45 degree angle. So we have, basically, if you think about it, 4 pi over 4 is the same thing as pi. So I'm at least going to pi, that's pi, 180 degrees, and I'm going another 45 degrees, or another pi over 4. So 5 pi over 4 goes all the way to there. And again, this is something that you guys can do if you're not comfortable with working with fractions yet. You can do, convert it. Multiply 5 times 180 divided by 4. Alright, so to get, when an angle measures more than 360 or 2 pi, it becomes an angle of rotation, because it goes more than once around. So to find the angle, you either subtract multiples of 360 from the original, or you can add it if it's negative, depending on which way you're going. So you're either adding and subtracting. So think about it this way. I have 400, which means that if I go 360, then I'm left with 40 more degrees. So that means I'm going to go all the way around, and then I'm going to go, so that's 360, and then I'm going to go another 40. So it looks just like a 40-degree angle, except for I've rotated it once. So this would be 400. And for 17 pi over 4, I also like to think about this in terms of pi's. We know 4 pi over 4 is 1/2 of a circle because it's pi. 8 pi over 4 would be a full circle. I'm just going up by pi over 4s. 12 pi would be a circle and a half. 16 pi over 4 would be 2 full circles. And then we have, if we've used 16/4 and we need to go 17/4, we have 1 pi over 4 remaining. So my last part will be pi over 4. And again, if you cannot see that with the fractions, convert this, you would get 720 plus 45, so 765 is what you would end up with, and you can just wrap it around twice. So here's 1 circle, here's 2 circles, and we are at pi over 4. So that would be 17 pi over 4. We go around 2 full times, and then we have a pi over 4 remaining. Alright, any questions? Nope? Alright, good. Well, then I'll keep going. Reference angles. Now, all angles have reference angles. Sometimes the angle itself is the reference. The reference angle is the acute angle. Well, it could go up to 90 actually. It could be a right angle as well. Formed between the terminal side and the x-axis. So, it's always positive. So for example here, if I have an angle that goes from here to here, this would be my angle. My reference would actually be the acute angle from the x-axis, so here's my x-axis, to here. So it would be this angle right here. This is my reference. Okay, and we always measure it positively. So we would say, let's say this was 135 degrees. We would say that the reference is 45 degrees. So let's talk, so that for these problems I want to know what are the reference angles. Well, if I go 120, how much more do I have to go to get to 180? Hopefully you guys know that 180 minus 120 is 60 degrees, is my reference angle. So that's my reference angle. Over here, well, again, the definition of a reference angle is that it's measured from the x-axis up to the terminal ray, and it's less than 90, or less than or equal to 90. So, in this case, the reference is the same thing as the angle. The reference angle is 45 degrees because it's also from the x-axis to the terminal ray. If we went this way, that's bigger than 90 now. That's not the reference angle. So when you're in the first quadrant, the reference angle is the same thing as the angle itself. Okay, negative 527. Let's draw this one first. I'm going backwards though, so I have negative 527. If I add 360, I get negative 167. Okay? So I know that I'm going to be good after 180. But first, we'll deal with that in a second. Let's go and actually draw this. So 567, we get 360 plus another 90 is here, 450. And then another 90 would get us to 540, but we're not going to 540, so we're going to end about here. So, wrapping all the way around, we get negative 527. So let me go back to what I was doing here. So if I wrap around once, I'm at negative, I have this piece from here to here is negative 167. How can I get this piece that's missing over here? Well, I need some more to get to 180. So I'm going to add 180 to see what I get, and sure enough it's 13 degrees. So this piece that's missing is 13 degrees. So my reference is 13. Okay, last few things. Coterminal angles. That means they share a terminal ray. So it's like saying here, this is 90 degrees, just from 0 to 90. 450 goes 360 and another 90. both angles end up in the same position. It's just that you go around a circle once for 450, where 90 you didn't go at all. Alright, so last problem, sketch the angle, state the reference angle, and here's the thing I want to maybe star this. When you state the reference, you need to state it in the same measure. So if I give you a problem in radians, like this one is here, if this is in radians, my reference angle should be in radians. Do not give it to me in degrees, because you will be wrong then. If I give you an initial that's in radians, then the final should be in radians. So sketch it, state the reference, and then we're going to convert the original to degrees. Now you can do this part first if it helps you out. So let's say you wanted to do this part first, to convert the original to degrees. We have -10 thirds pi times 180 over pi. Okay? And you get -600 degrees. So we know that we're working with -600. So let's do that one. So we have -360. Okay. Then a -360 plus 180 is 540. And then we have another 60 to go. So it's up here. So this would be -600. Oh, and I shouldn't have written that though, because again, I almost did what I told you not to do. We are in radians, so that is -10 pi over 3. Now here's an easy way to figure out this reference angle without doing a lot of math here. Think in terms of thirds. 3/3 is half a circle. So I'm going to go around. Half a circle is 3/3, another half is 6/3, another half is 9/3. How much more do I have remaining? One more pi over 3, or 60 degrees. So the reference angle for this problem is a positive pi over 3, because we always state the reference angle in terms of positive radians or degrees. Okay, so we're going to do a couple more of these in class when you guys get there on Wednesday, and then we will I'll let you go and practice them yourself. Alright, I will see you guys on the next video, which will be in 2 seconds.